Hey everybody, this is Miss Eisencraft, and I wanted to do a couple of the station reviews by video in case you were stuck. So maybe this was a tricky one. Okay, a four-sided die shaped like an asymmetrical tetrahedron has the following roll properties. So X is the result of a single roll. So you can get a 1, 2, 3, 4, and there are the probabilities. So not equally likely. So this is asking what's the probability of getting the result of a single roll being greater than 1 but less than 4. So basically a 2 or a 3, right? So what's the probability of getting a 2 or a 3? You would just add these up, okay? So 0.1 plus 0.2 is 0.3. There you go. Okay. Find the probability of not rolling a 3. So not rolling a 3, well, rolling a 3, you could do the complement is a 0.2. So you could go 100% minus basically 20%. Or you could add up everything except for the 3. 0.3 plus 0.1 plus 0.4, that is 0.8. Okay. Now this is where it gets a little bit weird. If T is the sum of two rolls, find the probability that the sum will be 4. So these are independent of each other, meaning the die has no memory, not like a deck of cards if you pull one and then pull another, right? Like everything's equally likely, not equally likely. The probability, this stays the same both times you roll, every time you roll. So I think it's easiest to say you could do a tree diagram. You don't have to, but you could say, okay, you could roll a 1 the first time, roll a 2, roll a 3, roll a 4. Okay, the second time you roll, so from a 1, it could be a 1, 2, 3, 4. 2, 1, 2, 3, 4. We're going to run out of room. 3, 1, 2, 3, 4. A 4, 1, 2, 3, 4. Okay, that's a hot mess. So what you're saying is, where do we even have a sum of 4? Well, a 1 and a 3 would make a sum of 4. A 2 and a 2 would make a sum of 4, and a 1 and a 3 would make a sum of 4. And it might have been easier to see that if you would have done like first roll, since you're only doing two rolls, right? You could do a table. You could roll, and so the sum of 4, right, is the 2 and the 2, the 1 and the 3, and the 3 and the 1. Those are the only ways to get a sum of 4. So what you're going to do is you're going to multiply those probabilities. So I had to reason through that first. So you could get a 1 and a 3, roll a 1 and a 3, that's a sum of a 4. So you're going to multiply those probabilities. You could roll a 2 and then a 2, that's a sum of a 4. Or you could roll a 3 and a 1, and that's a sum of 4. So we're saying what's the probability of both of these things happening? Well, a probability of rolling a 1 is 0.3. Then you're going to multiply that by the probability of rolling a 3 next. So that's 0.06. Yes. 2 and 2 is 0.1 out of 10 chance. 1 out of 10 chance. That's a 1 out of 100. And then a 3 and a 1 is just this flipped. 0.2 times 0.3 is 0.06. So all of these together, this could have happened, this, we're going to total that up, right? Which is 0.13. That was a little bit of fun, huh? So again, the whole reason of doing this was to see the possibilities of getting a sum of 4 and then calculating those probabilities. They are independent, right? So you are multiplying. I believe that is in your handy dandy notes. I'm going to show you just because I have it. We summarized it. If they are independent, we wanted to know what's the probability of rolling a 1 and then a 2. No, just kidding. It was a 1 and then a 3, a 2, and then a 2. So you're going to multiply them because they were independent. You didn't have to change the probability the next time. So that was, you didn't really need to associate it. You could kind of didn't have to know this notation, but that's basically what we did. Okay. All right. Find and interpret the mean. So the mean from based on a probability distribution, right? You just kind of weight the mean. So you're going to multiply. So the mean of X is 1 times 0.3 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.4. And that was in our notes right about, oh Lord. Right here. Good times. Right. The sum of the possible value times its probability. Okay. So, if I don't make a mistake, I'm going to get my calculator out. 1 times 0.3 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.4. I get. Okay, so this is weird. It's a 2.7, and that's not even a possibility, but you still say it. Okay. The result of a single row, the average is a 2.7. Right? You can't get a 2.7, but you still say it. Because you do. All right. Hope that helped.